morning. Great to see you guys. Today is Monday, May 4th. You guessed it, it's Star Wars Day. Woo! Okay, so we're going to do a little math for you guys today. I know that Mrs. Widener did a good job the other day of describing the different types of angles that you're going to see. This is an example of a right angle. We call it a right angle because it's just right. 90 degrees. Or square angle. You'll see a lot of these around your house, in different buildings, with blocks. Right angles are everywhere. So it's a right angle if it's perfect 90 degrees. She talked about some other types of angles too. This is an acute angle. Aw, he's so cute. He's a cute angle because he's less than 90 degrees. 90 degrees would be a square angle. This one, he's a cutie. Less than 90 degrees. The other kind of angles that she talked about was an obtuse angle. Obtuse. Kind of sounds like obese, obtuse, because he's bigger than 90 degrees. If he had been a 90-degree angle, it would have stopped right there at the dotted line, wouldn't it? But he's bigger than 90 degrees. And finally, the straight angle. 180 degrees. It's a straight line. It's a line because there's arrows on both ends. It goes on and on and on and on and... Sorry. So it's 180 degrees. What do you already see that you already know? I know that a 90-degree angle is right here, and I know that 9 plus 9 equals 18. So I just add the 0 at the end. 90 plus 90 equals 180. Wow. Math is cool. Well, I think it's cool. So if that is a straight line, it also looks like half of another shape. What shape do you think that looks like? Okay, it looks like a circle. Half a circle. A circle is made up of 360 degrees. 360 degrees. When you hear somebody in a sport like skateboarding or motocross or something like that, they did a 360. That means they went in a complete flip or a complete circle. 360 degrees. Now, I taught you all that to ask you the following question. If a clock shows it is 3 o'clock, how could you describe the smaller angle made by the two hands of the clock? If a clock shows it is 3 o'clock, how could you describe the smaller angle made by the two hands of the clock? I really wish I had my Mickey Mouse watch to show you, but this'll do. Here is a clock, and it's showing 3 o'clock. We've got the long hand pointing to 12 and the short hand pointing to 3. The angles that we're talking about here, we have one angle here, and we have another angle here. Okay? Two different types of angles, aren't they? So, which one is smaller? Is it A or B? Which angle is smaller? You guessed it. It's A. I knew you knew that. Angle A is smaller than angle B. But how would I describe that? What's some words that we just learned that I could use to describe angle A? What do you guys think? I know one. I could say that this is a right angle. I could say that angle, or smaller angle, the smaller angle, because that's what the question asked. We got to make sure we answer what the question asked, is a right angle. Would that work? I think so. I could also write the smaller angle, oopsie, it's hard to write with one hand like that, is, what else could we say about that? We know that it's a right angle. What else do we know about right angles? That's right. They're 90, whoopsie, woohoo, sorry, 90 degrees. The smaller angle is 90 degrees. So did we answer our question? If a clock shows it is 3 o'clock, how could you describe the smaller angle made by the two hands of the clock? The smaller angle is a right angle. The smaller angle is 90 degrees. I think we answered our question. Good job. Now, for the next part, this is kind of cool. I'm going to give you guys something to work on, and I will show you the answer tomorrow. At 3 o'clock, what two fractions do the hands divide the clock into? At 3 o'clock, what two fractions do the hands divide the clock into? So I'm going to have two answers. So I could put a fraction bar here and a fraction bar here. All right, guys, try solving this problem on your own. And then tomorrow, I will give you the answer. Make it a great day, because it's a great day to be a Wildcat. Oh, yeah.